Hello everyone, now I'm here with my next video of iterative construct in Java. I told you so many types of numbers we are having. I'm here with the next video for numbers. Now I'm considering the few numbers. First one is Niven number. Niven is basically a number which is divisible by sum of digits. Means example, if I'm taking 126, the sum of digits is total is 9. 1 plus 2 plus 6 is 9. And 126 is divisible by 9. Means in this, I have to focus on sum of digits. Means one by one I have to pick digit and I have to add them. And I have to develop a number by adding digits one by one. And I have to check whether the sum of digit is going to divide a particular number or not. Now how I'm going to do that? Now my number is 126. I had written here the logic of sum of digits. Means number is 126. I'm storing it in sum. I'm using while. Why I'm using, I'll tell you later. From here I'm picking digits. From here I'm having the quotient. Divide is used for quotient and mod is used for remainder. I'm storing remainder and adding remainder one by one. Means firstly I'm picking a digit 6, then I'm picking a digit 2, then I'm picking digit 1. How I'm going to do that? Means from 126 mod 10, if I want to pick a digit, then I will mod it with 10. What I'm getting? See, when I'm mod it with 10, what I'm getting? The quotient is 12, remainder is 6. Means here I want to add this 6. Means value of sum is 0. I'm adding 6 with sum. It becomes 6. Now I'm storing the quotient in num only. Means I'm storing the quotient in num only. Now what I think I'm doing second time also. See how? In this way. What I had stored as quotient in num, now num is 12. Num is going to be divided by 10. And what I'm getting as quotient, that is 1. Remainder, that is 2. Already sum is equals to sum plus digit. Sum is 6. Digit is now 2. 6 plus 2 is 8. And I'm storing my quotient in my number. See here. And this is my second attempt of doing the same thing. Now I'm doing the same thing again because number is greater than 0. This I'm doing the same thing again because number is greater than 0. I have to add the remainder with the sum. Already sum is 8. 8 plus 1 is 9. Now see, I have to put my quotient in my number. And see, I'd already put it here. In the last you can able to see num equals to 0. This is my third attempt. Now if I'm checking whether my number is greater than 0, no, it is not. Means in this way I'm having the sum of digits. In this way we can have our sum of digits. 6 plus 2 is 8 and 8 plus 1 is 9. Now we have to apply this logic in Niven. Because we want sum of digit and then we have to divide our sum of digit with the original number. See, original number is 126. I already stored in 1. I made one copy of original number. Means num is 126. I am storing 126 in P also. Because when I am rotating the logic for finding the sum of digit, num becomes 0. In what I am having, see, I told you in this logic, with the help of this we are having sum. And now what we have to do, we have to divide our original number and we have to check whether 126 is completely divisible by 9 or not. How we will find it whether it is completely divisible or not? If we are getting remainder 0, it means the number is completely divisible by 9, then it is said to be Niven number. If a number is completely divisible by sum of its digits, then it is said to be Niven, else it is not. This one is sufficient for you all so that you can able to create your Niven number program. And when you want to accept a number from the user, here you have to accept a number. You can accept it by integer.parseInt, or you can accept a number by using scanner also in .nextInt. It's on you what you want to do. I created one logic with the help of assignment. You can create it by input statement or you can create it with the help of scanner. It's on you. Now the next one, that is spy number. Spy number is a number which is whose sum of digits is equals to the product of its digits. For example, if I am taking 1124 means 1124, the sum of digits is 8 and product of digit is also 8. Means a number whose sum of digit is equals to the product of its digits. That is said to be spy. But how we are going to do that? I told you how we are going to find the sum of digits. Now you have to find the product of digit also. For product, you all know, for sum we are using plus, we are using asterisk for product. The same thing we are doing here. When we are writing sum is equals to sum plus digit, when we have to find the product, we have to write product is equals to product into digit. That's it. The same thing I'm writing. But when we initialize sum, we are using 0. When we initialize product, we have to write 1. Because when we multiply anything with 0, it becomes 0. Anything with 0, we can write any of the number, it becomes 0 only. That's why I'm using 1. If I'm multiplying any number with the 1, what I'm getting the same number. That's why the initial value of a product is 1. I'm using the products and the sum part by doing the same process what I told you earlier. The same process I'm doing here, and I'm picking my digits, I'm storing in sum, I'm picking my digits and storing products. In this way I can have my sum and the products of digits. This logic I have to use in my logic of spy number. I have my number. See here I am having my number, that is 1124. I'm initializing product with 1, initializing sum with 0. The same logic I had written here. When the product and sum both were equal, then it is said to be spy. And if it is not, then it is said to be not a spy number. I think this is sufficient for you all. Go with this. You can have these sort of logic in switch also. Maybe some sort of question is appearing in front of you, that if user want to provide you 1, then you have to check whether the number is Niven number or not. And if user provide you 2, you have to check whether a number is spy number or not. The same logic you have to put in case 2, and the Niven logic you have to place in case 1. That's it. You can have these sort of programs in switch cases also. Now do practice all these kinds of programs, and if possible then run your program also. If you have any doubt, do consult with me. Otherwise, goodbye and good luck.